Good morning, ladies and gentlemen. It gives me great pleasure to join you today on this very important panel discussion on the implementation of geospatial technologies and building information modeling for smarter cities. I'm pleased to be here to represent the World Federation of Engineering Organizations as its immediate past president. The World Federation of Engineering Organizations is the peak body for engineering organizations globally. We have members in some 100 nations representing more than 30 million engineers. I'm very pleased that the World Geospatial Information Council is an important associate of the Federation. A key objective of the World Federation of Engineering Organizations is to advance the UN Sustainable Development Goals through engineering. This vision and narrative was developed during my term as president of the Federation, and it's also has developed an imperative to build capacity to understand how technology and advanced engineering can be used for sustainable development. And of course, the use of geospatial engineering and advanced building information modeling meets this objective as well. We need to build capacity for the implementation of these technologies. It is for this reason that the World Federation of Engineering Organizations and the World Geospatial Information Council came together in 2019 during my term as president for a collaborative project to demonstrate how such technologies can be implemented. We are very pleased that we were joined also by the United Nations Committee of Experts on Global Geospatial Information Management. The project resulted in a white paper that was launched at the United Nations High-Level Political Forum in July 2020. The white paper brought together experts and leaders from around the world and demonstrates the importance of geospatial information. It builds capacity by demonstrating case studies of successful implementation of these technologies around the world. It identifies critical challenges to implementation, and it recommends approaches on addressing these through the framework established by the United Nations Committee of Experts, Global Geospatial Information Management. So why cities? In 2019, the United Nations launched the Global Sustainable Development Report on progress in sustainable development, and it identified science and engineering as one of the 4 levers to accelerate sustainable development. And it also identified urban and peri-urban environments, in other words, cities, as one of the 6 pathways that can accelerate transformation for sustainable development. So here we have the framework and urban and peri-urban environments, and we have the lever of science and technology. And at that confluence, we have, of course, smart cities. So this demonstrates the importance of this topic of building back better, smarter cities for sustainable development. And why sustainable cities? Sustainable cities are central to achieving all the 17 Sustainable Development Goals, because by 2050, cities will have approximately 70% of the world's population and produce 85% of the world's economic output. And of course, your urban development needs to be well planned, integrated, and inclusive, and access advanced technologies for cities. Sustainable cities should prioritize access to jobs and affordable housing, healthcare, education, sustainable transport, and attractive public spaces for all. Sustainable cities should promote sustainable consumption and production and consider environmental impacts and resilience to natural disaster. Each one of these objectives incorporates one of the or more of the Sustainable Development Goals. And of course, sustainable and livable cities have a close connection between people and nature to enhance human health, well-being, protect biodiversity, and strengthen climate change resilience. Geospatial information, of course, brings together digital information about a place. It reflects the physical world in a digital version. It brings together not only physical location data, but other associated data and presents this in various layers. Map, satellite imagery, aerial photography, etc. are brought together. And this information enables city governments and administrators to plan a better city because it can incorporate land administration and property ownership data, urban planning and land use information, transport networks and hubs, health infrastructure, education facilities, the location of water networks and facilities, nature reserves and parks, natural disaster prone areas, and it can also incorporate population and income data for the planning of the future of the city, and most importantly, the digital infrastructure, telecommunications, mobile, and broadband. And all this data also enables social and economic policies such as smarter transportation and energy use, better environmental management and waste management, information for citizens and their engagement, investigation of crimes, health and education, recreation, and affordable housing. Building information modeling also enables a digital twin, but of a construction project, such as an office building, hospital, sports stadium, school, university, airport, railway station, or a precinct within a city, and enables all this information to be brought together in a digital format so that architects, engineers, and construction professionals can plan, design, construct, and manage these buildings during construction and in the future. It enables different options to be considered at the design stage and optimization on energy use, materials, and also better operations and efficiency. During construction, it facilitates collaboration and communication between the various teams, reducing costly mistakes, sometimes even before you get onto the construction site. And so building information modeling very much enables cities to build back better. I present here a case study from the white paper that was released in July on the use of geospatial information in the city of Lisbon, Portugal, for drainage management and flood mitigation. Geospatial data includes terrain information, mapping of water, sewage, and stormwater networks, real-time sensor information, video surveillance, and public reporting. This has enabled the modeling of the city's water and stormwater networks and predictive analysis on capacity limitations in flood events. It has enabled the development of appropriate planning for infrastructure to increase capacity and facilitate emergency response. This has greatly reduced events that resulted in significant inundation, and this is increasingly important as sea level rise increases with climate change impacts. And here I have the digital twin of my home city of Sydney, Australia. This digital twin is set to transform urban planning and design using spatial data of the built environment today and tomorrow. It can be readily accessed real time in the link that I have shown here. The data integrates real-time transport data, information on above and below ground utilities, electricity, gas, water, and broadband, building information, property data, health and education facility, information on trees and the canopy cover, roads and buildings. And so this comprehensive data is expected to enable the city government to build back a better city. And of course, we cannot leave this presentation without talking about COVID-19 in this most extraordinary year. And here we have real-time information from ESRI, which again shows the spread of the COVID-19 virus globally in real time. This data was captured on the 27th of November, just 1 week ago. Such data is being used by governments to track the spread of COVID-19, not just in cities, but across the country. It captures data using various sources, including credit card transactions, mobile phone locations, to track and trace locations of confirmed cases. It enables policymakers to implement travel bans and lockdown policies. And medical services, such as hospitals, can be supported based on location and trends in cases. So you can see that geospatial information technologies and building information modeling are crucial for building back better and sustainable cities because they enable better services for people. They enable better work and economic growth. They enable innovation, especially in the provision of critical water and electricity services. They enable responsible consumption and resilience against climate change, and they enable stronger and better institutions, especially local and city governments, in planning better cities. So this demonstrates the importance of geospatial information technologies and building information technologies. Thank you very much.